In this video, I'm going to show you where does the three Pythagorean identities come from. All right. So without wasting time, let's get to it. So firstly, let's draw a Cartesian plane. So this is my Cartesian plane. All right. And then I'm going to draw a right angle triangle in the first quadrant. All right. And then this angle here, we're going to call it theta. And ladies and gentlemen, we know that this is the x-axis, so this length here I'm going to call it x because it's the x-axis. Then this length here I'm going to call it y, né? Because this is parallel to the y-axis, so the length must be the same. And then this one here we're gonna call it r, né? For the hypotenuse. Sometimes we can call it h. It's entirely up to you, right? Perfect. And then we have three trig ratio definitions, right? We have sine theta, cos theta, and tan theta, right? And there's a phrase that we use to help us remember. These are trigonometric ratios. So we have sine theta is basically up over hypotenuse, right? And then cos theta, we know that this is adjacent over hypotenuse. All right. Awesome. And then let's see now. And we have tan theta. Tan theta equals to opposite over adjacent. We use this phrase so ka toa, sokatoa, ne? Sokatoa. If you check on sokatoa, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. All right, perfect. But we are interested in the cosine and the tan, so I'm going to erase. We're interested in the sine and the cosine. So let's erase this one. Let's erase this one because we need those two. Awesome. So now let's see. We're going to do this. From the diagram, we can see that, okay, sine theta, right, is basically opposite. Remember, the opposite of theta is what? It's y. You see, this is the opposite of theta, and this side is the adjacent of theta. So x will be the adjacent, and then r will be the hypotenuse. So the opposite is y over r, right? Now, if I'm looking for sine square theta, I'm just going to square this side as well, right? So it's going to be y squared all over r squared. All right. And then similarly, if I'm looking for cos theta, I can see that it's adjacent, which is my x, over the hypotenuse, which is the r. And then if I'm looking for cos squared theta, we're going to just square them, right? Because we're squaring the right hand side, we also need to square the left hand side. So there, right? Awesome. And then if we check the first thing, the first Pythagorean identity, we have sine squared theta plus cos squared theta equals to 1. We are going to prove that now. Before I proceed, let's all agree that r squared equals to x squared over y squared. Plus y squared, right? R squared is the same as x squared plus r squared. Plus y squared. So ladies and gents, so we're going to do this. We're going to say, okay, r squared is the same as x squared plus y squared. Using the theorem of Pythagoras, né? You must show that here we used Pythag. Awesome. And then let's move this up. Now guys, let's see what is the sum of sine squared theta plus cos squared theta. We can see that sine squared theta becomes it becomes y squared over r squared, right? And then the cos squared theta becomes x squared over r squared. And then from here we can see that, okay, sine squared theta plus cos squared theta is the same as y squared plus x squared all over the common denominator, which is r squared. Remember, r squared is here on the y squared and is also the denominator again on the of the x squared. So we're going to just write the fraction under a common fraction. All right. But ladies and gentlemen, remember this. We just proved earlier on that r squared is the same as that, right? So which means the top we can replace by r squared. Then the bottom, there's r squared. So r squared over r squared equals to 1. So we have proved the first Pythagorean identity, that that sine squared theta plus cos squared theta equals to 1. We just showed it there, né? Perfect. And then to prove the other two Pythagorean identities, we have to use this one, né? The sine squared theta plus cos squared theta equals to 1. Before we proceed, I need us to acknowledge this. You must know that cot is the opposite. Okay, we have cot, we have cosec, we have sec, né? We have a secant. So I want us to observe the third letters. This is C, the third letter there is S, the third letter there is tan, right? So cot is the opposite of tan, basically, né? It's a reciprocal of tan. So in simple terms, cot is basically 1 over tan. You see? Cosec is 1 over sine because the third letter is sine. See, let me just say theta here to make it official or more formal. There, right? And then sec, the third letter is cos. So sec, the opposite of what? Of cos. So it's 1 over cos theta. All right. So we're going to use these three ratios to create the other two Pythagorean identities. All right. So we are going to do this. We are going to say, okay, we have, okay, this one I'll call it A, né? That is, now let's prove B. So to prove B, we have sine squared theta plus cos squared theta equals to 1, right? Awesome. And then let's divide everything by sine squared theta, né? So I'm going to divide everything by sine squared theta. Even here by sine squared theta. Even here by sine squared theta. Right. Now let's see what we get. Let's move this up. So this is what we get, ladies and gents. Remember, sine squared divided by sine squared will give you 1. Plus, remember here, you have cos over sine. That is the opposite of tan. Remember, tan theta is sine over cos. If you have cos over sine, it means you have 1 over tan theta. So here we have 1 over tan squared theta because they all have squares, right? And then here, remember, 1 over sine, we said is cosec. But because there's a square, we'll put a square there. So you have a cosec squared theta. But 1 over tan squared is cot. right? If we go back here, we've shown that 1 over tan, it's cot. Do you see it? 1 over tan. We have shown that 1 over tan. Let me just highlight them. We've shown that 1 over tan is basically cot. So I'm going to replace 1 over tan with cot theta. Okay, let's do that. So we can all see that we are now left with 1 plus cot theta. But I have to put a square because that one has a square. Equals to cosec squared theta. Alright, and that's the second Pythagorean identity. The third one, we get it the same way, but now we're just going to be dividing that by cos squared now, right? Okay, let me get an eraser so we don't need this anymore. Let's prove the third one, right? So I'm just going to leave that there. Okay, perfect. So now, ladies and gentlemen, let's check this. We have basically now a division by cos. Ne? So here I'm going to divide by cos squared theta. Also here by cos squared theta. Also here by cos squared theta. Remember your reciprocals. Ne? Sine over cos is tan. Remember, that is a normal grade 11 identity. Sine divided by cos is tan. So here we're going to have tan squared theta. Tan squared theta. Cos squared divided by cos squared is 1. Remember, the reciprocal of cos is sec. Right? I can go up and just remind you. Remember, we said cos, the third letter, cos, it's here. So the third letter is there. It's cos. So 1 over cos is basically sec. You can see it here, guys. 1 over cos is sec. Right. So let's proceed. So here we have this now. Ne? We have that. Let's see. So we have sec squared theta. And that is the third Pythagorean identity. If you found this video helpful, please don't forget to share with family and friends. And hit the like and leave a subscribe button and leave a subscription. And maybe comment also on any question paper or any question you would want me to solve. Right. Thank you very much. Aluta continua. Tango.